Okay, we are given 2.1. We have a diagram there of a girl sliding down a slide. And then A says, state the principle of conservation of mechanical energy. Let's run quickly to that. We know that conservation of mechanical energy states that the total mechanical energy in an isolated system is conserved. And then B says a girl slides down a slide. She begins 2 meters above the ground. So let's highlight that. So 2 meters here, that's our height initially. And then from rest, so she slides down and then begins from rest. We know that when we see the word rest, it indicates that our V initially is 0 and then experiences no friction. So no friction. From this, you can see that the hint here is that they made us state the principle of conservation of mechanical energy, and we know that we apply the formula for this one when we have no friction, right? So we are also told there that the girl experiences no friction. Then they say use the principle of conservation of mechanical energy to calculate her speed. So her speed here, the speed that they're looking for is the V final when she is 50 centimeters above the ground. Now you can see there is something wrong with this. It is in centimeters, right? So that means we have to convert this centimeters into meters because we never have our distance or height in centimeters, but we must have it in meters, right? So as our first step for B, we can just start by converting that 50 centimeter to meters. So we have to divide by 100, and then this will give us 0.5 meters. So this is the height that we are going to use. And what is this? This is our height finally. Now to use the principle of conservation of mechanical energy, here we go. We say sum of mechanical energy, let's say at point A is equals to sum of mechanical energy at point B. So you can say initially, you can say after, either way you want to have it. So here we have mgh, because remember mechanical energy is the sum of the object's potential energy and kinetic energy. So here we have the potential energy initially, and then we have the kinetic energy initially. Then on the other side, we have the potential energy finally plus the kinetic energy finally. Now from this, we can just substitute here. It's just a matter of substituting. But reading there, we could see that we are not given the mass of the girl. So that means we only have m there, no value for m. Then you just have to trust in the process of maths. Eventually, the m's will cancel out. Then this is height initially. What is our height initially? They gave us 2 meters. So we substitute it there. Then we have half m. Remember, again, we don't have the mass. And then v initially, we are told that the girl starts from rest. So that's 0. And then here we have m, our g 9.8. Then height finally, we calculated it to be 0.5. And then plus half m. We don't have the v finally. That's what we are looking for. So vf squared. Then okay, now we have question 3. It says a bus of 2000 kg is driving up an incline. The engine starts a force, or the engine exerts a force of 20,000 Newton on the bus, and the bus experiences a 1,200 Newton frictional force. The bus travels at x with a speed of 3 meters per second. So at x, the speed is 3 meters per second, and at y, the speed is 3.1 meters per second. The distance between x and y is 4 meters. So that is the displacement. We are given the displacement. Calculate the difference in height between x and y. So having to calculate that one, we can approach it this way. So here, what I would like to first do is to draw the free body diagram just to indicate the forces that we have there. So we have the FG parallel sliding down, and then we will have the FG perpendicular. Then up there we have the normal force, and then since it's the engine exerts a force, that's a force applied. We can call it force of the engine, force applied. And then acting down the slope again is the frictional force. It opposes the motion of the object. So this is what we have. Now from this, I can choose to use the WNC formula, since I can see that I have two non-conservative forces, which is the force applied and the frictional force. So I can use the work done by non-conservative forces. Then where I go, work done by non-conservative force is equals to change in EK plus change in EP. Why am I using this one specifically and not the W net? It's because with the W net, you can see that there is no way I can get the height here. Remember, W net is equal to change in EK, and with EK, I only have half M VF squared minus VI squared. So there is no height here. But remember, the question is asking me to calculate the difference in height, which is your change in Y. So this is what I'm looking for. This is why I'm choosing the work done by non-conservative force formula. So what are my non-conservative forces? This is the force applied, the work done by the engine, plus the work done by the frictional force, kinetic frictional force. Now, since I have this, I can break it down. This is half M VF squared minus VI squared plus mg. And then remember here, I have height finally minus height initially. But then remember, I'm just looking for the difference in the height. So I can just say change in Y here, right? So that will be your height finally and your height initially. Okay, 3.2 says a man pulls a wood block up an inclined plane. The mass of the block is 10 kg and the kinetic friction coefficient between the block and the surface is 0.18. So note that we are given the coefficient of kinetic friction, meaning we still need to calculate our kinetic friction using the formula mu k times n. Then the block accelerates from 2 meters per second to 3 meters per second. So we are given the v initially and the v finally, while traveling a distance of 3 meters. So we are given delta x. Then A says use energy principles to calculate the magnitude of the applied force. So before we can do anything, let's start with our free body diagram. We know here we'll have our FG perpendicular, then straight up in line it will be our normal force. Then obviously here we have our force applied, and then this will be our FG parallel sliding down the surface. And then in that same direction will be our kinetic frictional force. So this is how we'll have our free body diagram. Now let's start calculating. We must use so we have Fk is equal to mu k times n. Now to calculate Fk, our mu k is 0.18. Then what is our normal force? Looking at our free body diagram, we can see that on an incline, the normal force is equal to the Fg perpendicular. So in order to find the value or the magnitude of the normal force, we say normal force is equal to Fg perpendicular. But Fg perpendicular is mg cos theta. So we can just go ahead here and substitute that. This is mg cos theta, right? Then we have 0.18. Then what is our mass? 10, and then 9.8 cos 30 degrees, right? That's the angle of the incline, 5.28 newtons, right? Now, from here, we can now use the formula, the work net theorem, or the work energy theorem. The work energy theorem, from this one, we can see that looking at our free body diagram, the forces that will be doing work on this energy or on this diagram or on this block will be our Fk, Fg parallel, and force applied, right? Fn and Fg perpendicular, they're not doing work because they're perpendicular to the displacement. So on our W net formula, we'll only be focusing on these three forces. work done by force applied, plus work done by Fg parallel, plus work done by Fk is equals to half m Vf squared minus Vi squared. Okay, now B says calculate the power dissipated by the man. Calculate the power dissipated by the man. Now for power, we have two formulas, which is P is equals to W over T. This is where we get our definition for power, the rate at which work is done. So this is work over change in time. But then seeing from that, we were not given the change in time, right? Another formula is the P average formula, whereby we have the force multiplied by the V average. So this is the applied force multiplied by the V average. We just calculated the applied force in the previous question. So that means the one that is perfect for this one is this formula. Now using the PA formula is equals to F multiplied by V average. The force that we calculated is 72.61. But the V average will be an addition of these two velocities over 2. So that's how we calculate the average. So we just add these two velocities that we've been given and divide it by 2, right? So if you multiply all this, it will give us 181.53 watts. Awesome.